Hello, welcome to all of you. Today, this is my first video online class in this topic. With the topic name is Maxwell's thermodynamical relation, and this topic is helpful for degree 1 honors and subsidiary student. Let us see how to derive the Maxwell's thermodynamical relation. With In this topic, we will see how Maxwell's thermodynamical relations are obtained by using first and second law of thermodynamics. So let us recall the first law of thermodynamics. You can see here, this is the first law of thermodynamics, which states that dq is equal to du plus pdv. You know that the amount of heat energy dq is used in two ways. A part of it is used to raise its internal energy, and second, it is used in doing work. Here pdv is the work done. And now equation 2, which is the second law of thermodynamics, dq is equal to tds. T, what is T? T is absolute temperature and ds is the change in entropy. Again I am saying that dq is the heat. So now we are going to combine equation 1 and 2, that is first law of thermodynamics and second law of thermodynamics, and with the help of these two equations we get du plus pdv is equal to tds, because left hand side dq, left hand side dq, these two are equal, so du plus pdv is equal to tds. This equation may be rewritten as du is equal to tds minus pdv. You can see here this pdv is taken this side and this is plus, so on right side it becomes minus. That is why I have written here du is equal to tds minus pdv. Okay. Now in equation 3, it is du, u is internal energy, tds, s is entropy, and v is volume. So this is perfect du, tds, pdv. Here we represent this relation in terms of two variables. Either whether we want to represent u or s or v, we represent them in two independent variables x and y, which will determine states of the substances x and y, maybe any two of the quantity p, v, tu. P may be x, P may be y, V may be x, V may be y, T may be x, T may be y, U may be x, U may be y, and finally S may be x, S may be y. Okay, so du, as I told you, U is the function of x and y. So we differentiate it partially, first with respect to x and then with respect to y, and similarly we differentiate ds, we get dv. And now after getting du, ds, dv, we put them in equation 3. You can see du is equal to tds minus pdv. So let us substitute the value of du, ds, dv, and we get this one. This is du, this part left side is du, then t and this is ds, and this is pdv. Okay, with the help of this equation we can see that this one is the component, this one is the coefficient of dx, this one is the coefficient of dy, and in the right hand side the two terms, this one and this one, these are coefficient of dx, and this one last one, these are the coefficient of dy. So we equate them. We are equating here the coefficient of dx and dy separately. First we are equate the coefficient of dx. What is the coefficient here? You can see this one, del u by del x. I have written here. Here dx coefficient is del s by del x. Okay, and t. And here this is the coefficient dy. This is the coefficient of dx, p dv by dx with negative sign. So I am writing here. Similarly, we equate the coefficient of dy. This is the coefficient of dy. This is the coefficient of dy, and this is the coefficient of dy. We are After equating, we get two equation 4 and 5. Now again we differentiate equation 4 and 5 with respect to y and x. Let us see here. Equation 4. What is equation 4? Del u by del x. It is differentiated against x. Now we are going to differentiate again with respect to y. So we will write here del 2u by del y del x. Okay, and del x by del x, del s by del x, and this is t. Differentiating t with respect to y, differentiating del s with respect to y. So first we differentiate. This term is the product of two terms. So first we differentiate term t, and then we differentiate del s by del x. So we get this one. And similarly, we are going to differentiate this one. First we differentiate p with respect to y. We will get del p by del y, and then we differentiate del p by del x with respect to y. We get this term. Similarly, we differentiate equation 5 with respect to x because it is already differentiated with respect to y. So we are going to differentiate again with respect to x. Then it is del uy, del 2uy, del x, del y, and del t by del x. This one as it is. Now leave it t, and differentiation of del x, del s by del y with respect to x is this one, and similarly this term. In this way, we get to equation 6 and 7. Since del u or du is a perfect differential, so whether we differentiate with respect to y first or with respect to x first does not matter. Here you can see in the del y del x del y, they are same because du is a perfect differential. So we does not here it does not matter that which one is earlier, which occurs earlier, y or x. They are same. Del y del x or del x del y, they are same. So we equate these two equation, and after equating we get equation 8. Left side equal, so right side equal this one. Here x and y can be any two variable out of pvts, as I told you in earlier, uh, that p may be xy, v may be xy, t may be xy, x, s may be xy. So first let us assume x is equal to t and y is equal to v. If x is equal to t, then del t by del x is equal to 1. If x is equal to t, then del t by del y is equal to 0, because t, I have assumed t with x, so its differentiation with respect to y will be 0. Similarly, v is y, so its differentiation with respect to y will be 1, and with respect to x it will be 0. So, and substituting these values in equation 8, we get it is 0, del s by del y is equal to minus del p by del x, del s by del v, del p by del t. Okay, therefore del s by del v t is equal to del p by del t v is equal to 1. Why? Because you can see here this term del v by del x, del v by del x is equal to 0, del t by del y is equal to 0, but let us come here, del t by del x is equal to 1. So this term is 1, this term, and this term, del v by del x is equal to 0. So if this total term is 0, and del t by del y 0, total term. So left hand side total 0, right hand side this one is this term is 1, and this term is del v by del x, okay, del v by del y 1. So we get finally this one. Now equation, it is assumed equation 9. Here we multiply both sides by same quantity t. and we know that TdS is equal to what? Del Q. Okay, so we can write del Q. Either here you can see it is divided by T. First we multiply by T, then we divide by T to make it balance. Okay, one option is this, another option is you can multiply T from this side, this side, and you can multiply T by this side. Okay, so TdS is equal to del Q and del V as it is, del T del P by del T equation. This is the Maxwell first relation. Okay, here we had assumed x is equal to T, y is equal to B. Now we take another option. We assume x is equal to T, y is equal to P. If x is equal to T means del T by del x1. If y is equal to P means del P by del I is equal to 1. But if it differentiated, if we differentiate T with respect to y, it will be 0. Differentiation of P with respect to x will be 0. You can see here. And all these values are again substituted in equation 8. So after putting these values, we get this one. Okay, and again we multiply it by T and divide it by T. If we multiply here T, suppose T is taken this side, then TdS is equal to what? Del Q, and one T will be here because this T and T del S combinedly give del Q, but T is as it is here, so we get this relation, and this is maximum second relation. And similarly, we can proceed. One time we take x is equal to T, y is equal to B. Next time we set x is equal to T, y is equal to P. Third time it is x is equal to S, y is equal to B. So we can take pair by assuming S, T, P, B, X and Y, and we will get Maxwell's four relations. Actually, Maxwell derived six relations. We are not mentioning the other two relations because those are not important. Only these equations, means four equations are important, which is known as Maxwell's four thermodynamic relation. Thank you.